These are questions I put together from the 2015 Regents exams that relate to the topic solutions. Solutions, New York State puts under matter, but I like to break it apart a little bit, like solutions or gas laws or energy. There were 14 questions in 2015 under solutions, so let's take a look. Okay, in question 1 here, we're looking at determining the mass of potassium nitrate that dissolves in 100 grams of water, 40 degrees Celsius, to produce a saturated solution. As soon as you see the temperature there and the 100 grams of water, that hopefully will trigger that you're dealing with a solubility curve question, and that's reference table G. So potassium nitrate, I got to follow the potassium nitrate curve, and we're dealing with 40 degrees Celsius, so I'm going to go up to the line, and then I'm going to go over and try to read the graph. It also said it was in 100 grams of water, and I'm going to read it as maybe about 63 or 64 grams in 100 grams of water. And so I'll put down, let's say, 63 grams. It turns out that New York State accepted between 62 and 66 because it's hard to read between the lines. It's an estimation. Let's move on to 2 and 3. For 2 and 3, we're dealing here with this reading passage, so there's going to be some information up there that we'll probably need, and let's take a look. So for question 2, it says determine the concentration as expressed as percent by mass of the dissolved salts in the original sample of seawater. All right, so percent by mass. I'm not sure, then go to reference table T. Even if you are sure, it's always a good idea to take a look. Here is a percent by mass equation. It's pretty basic. Mass of part over mass of whole times 100. If I go back, let's use it. So we have the mass of the part over the mass of the whole thing times 100. Now, if you got this wrong or you weren't sure how to set this up, notice what I'm doing. I'm putting the equation down, and then I'm going to find the numbers to put into the equation. You should do exactly what I'm doing. It's easy to make a mistake. I know I've said it before. If you listen to any of the other videos, use a calculator also. All right, so I need the mass of the part. Well, I'm dealing with dissolved salts in seawater. So my salts are going to be my part. If I take, and then of course the seawater would be the whole thing, right? That's the water plus the salts. All right, let's go back in the reading passage. I have a 300 gram sample of seawater, so that takes care of the whole thing. And it's placed in an open container. After a week, all the water had evaporated. 10 grams of solid salts remained. That's my part. I'm going to multiply by 100. All right. So when I do that, I'm going to get an answer, and you're going to see it in your calculator, let's leave it as 3.3%. There is no indication about sig figs, so you'll be fine. That's 3 or 3.33. Let's move on to number 3. At standard pressure, compare the freezing point of seawater to the freezing point of distilled water. All right. In order to show you this, let me erase what we just did in question 2. And if you go back, by the way, and redo questions, make sure that you're actually doing them. Redo them with paper and a pen. It's always a good idea. All right. So here's the deal. When you have water, pure water, it freezes at 0 degrees Celsius and boils at 100 degrees Celsius. As soon as you dissolve something in the water, the boiling point raises and the freezing point drops, just because those salts are in the water. Okay? So, they're asking you about freezing points. So all you have to say is that the freezing point of seawater is going to be lower than the freezing point of distilled water. And you're done. All right. Check out the next video, or part 2, and we'll start with question 4.